So we're going to have three different methods for polynomial division, all right? We are going to be able to just simplify, very similar to what we did yesterday. We're going to use what's called polynomial long division, and we're going to equate some of that process, to a process of long division that we might have seen with numbers before. And then another process called synthetic division, all right? Those are the three methods we're going to use to divide. Simplifying, we're going to start there. Very similar to simplifying before and what we did yesterday, okay? The only difference now is instead of having just one term divided by another term, we're going to have addition and subtraction in our numerator, all right? The steps are exactly the same though. The only added layer that we have to do is kind of separate those things separate our numerator using some of our different algebra properties, okay? So I'm going to do the first one together, or the first one on my own. We'll do the second one together, right? In this first example, I have 4x squared plus 2y over xy, all right? Notice that I have addition in my numerator. Like I said, that's the difference between what we did yesterday and today. But the only thing that changes is I know that if I have the same denominator, I can write this as 4x squared over xy plus 2y over xy. Okay. So you just separate the numerator, but you can still divide it by each of the terms in the numerator, or still divide it by the same term in the denominator, excuse me. All right. And then what I'm going to do is just simplify that the same way I simplified things yesterday. So I look at my coefficients first. I know I'm still going to have a 4 there because it's 4 over 1. I go to my next term, which is x squared. I have x squared divided by x. Well, what's x squared divided by x going to give me? Just x, right? And it's positive. It stays in the numerator. There's no y term. I'm going to leave that down in my denominator. So that's as simplified as my expression can get for that first fraction. Any questions there? I'll do the same thing with the next fraction. I have 2 over 1, which is just going to stay 2. I have y over y. What's that going to simplify to? What's anything divided by itself?
One.
Just 1, right? So I'll have 2. The y's will actually cancel, and I have an x left in my denominator, so I just leave it. Okay? So this is how you would simplify now. Like I said, the only difference is we start by splitting it up, but then the process of actually simplifying is very similar to what we saw yesterday. Okay, remember that when we are dividing, we can only divide coefficients with coefficients, x terms with x terms, y's with y's. We're actually going to do this third example here instead of the second one. You'll see that you have 3 variables, so you can only divide each of those variables by whatever's underneath. Okay. Any questions about the first example? All right. We're going to take a look at the third example now. We're going to skip over the second one. You can use that as extra practice. And what's the first thing that I want to do now with this numerator, similar to what I did in the first example? How did I set up this problem? All right. So I take the negative 27 x cubed y squared z. I'm going to divide that by the denominator. Subtract from that 15 y cubed z squared over that same denominator. So the denominator doesn't change. And now I'm going to just take this step by step. So if I look at my coefficients in that first fraction, what's negative 27 divided by 3? Good. Negative 9. What's x cubed divided by x to the first power? X squared. That stays in the numerator, right? What's y squared divided by y cubed? Right, it's going to be y to the negative 1. So where do I put the y? In the denominator, right? And then z divided by z, well, anything divided by itself is just 1. So this is how I simplify my first fraction. This is all I have left over, right? These are going to cancel. Any questions so far? In the second fraction, negative 15 divided by 3. What's that going to give me? So I have negative 5. I don't have an x term, so the x term is actually going to stay alone in the denominator. Y cubed over y cubed, well, isn't that the same thing divided by itself? What's that going to give me? Just 1, right? And then what's z squared divided by z? Z, right? And that's going to stay in the numerator. It's positive. My highest exponent is also in my numerator, so that's where I remember to put that, right? Just like over here, we had y cubed in the denominator. That's higher than the y squared in terms of the exponents, so the y goes in the denominator. This is my final answer. So this is as simplified as I can get for this expression, okay? Any questions so far? So you can just drop the minus sign down. Either way, it's the same thing, right? Because you could just do 15 divided by 3. It'd still be 5, but then you have the subtraction sign in the middle. So it's all pretty much the same. Good question, though. Any other questions before we move on? Like I said, you can use that second example as extra practice. So that took care of simplifying. The next method we're going to discuss is what's called polynomial long division. Okay. The polynomial long division is another concept that we can use to help us divide out polynomials. Except now this time, if you were to rewrite this kind of as a fraction, you have addition and subtraction in both your numerator and denominator, right? Let's think about long division from before. Remember we used long division when we were trying to maybe take a number and divide it into a larger number. It looked something like this, right? And we asked ourselves, well, how many times does 9 go into that first number, 3? Well, it doesn't. So then we moved on to the next number. Well, how many times does 9 go into 36? We would write 4, right? And we just keep working from there. It's the same process here, except now we're dealing with variables. So we kind of have to ask ourselves, well, how many times does x go into x squared? And ask ourselves questions like that rather than dealing with numbers, okay? So what we're going to do is take this kind of step by step. Each note there is going to help us along the way. And we're going to deal with this first example, and I'll kind of walk through it together, okay? The first thing we're going to do is start by writing it like a long division equation. So we're going to take that binomial, that 2-term polynomial, write it on the outside. The 3-term or the trinomial is going to be on the inside. All right. Then what we're going to do is we're going to ask ourselves, how many times is that first term on the outside, so the x? How many times does that go into the first term on the inside, the x squared? Very similar to what we did with normal long division. In other words, we can ask ourselves, well, what do I have to multiply x by to get to x squared? So x times
X.
1. Right, good, x. And you see there, it goes in x times. We're going to write that above the x term. So you see here, I have the x squared term, x term, constant term. I'll write the x up here. Okay. So that's always the first thing you're going to do is just ask yourself, how many times does that first term go into the first term on the outside goes into the first term on the inside? Okay. Then what I'm going to do is multiply this value. So I'll multiply the x on top by each of the terms on the outside. Okay. Very similar to like when I got to this step, I would multiply the 4 and the 9. So I'm going to multiply the x by each term on the outside. And then I'm going to write that underneath my division sign. So what do I know is what's x times x? X squared, I'll write that here. What's x times 2? 2x. So you see this piece of our note, we're going to write the product on the inside of our division sign. But the biggest thing that we need to make sure we do, the reason that it's bolded, underlined, everything, is we're going to change the sign of each of those. So we know x times x gives us a positive x squared, x times 2 gives us a 2x, a positive 2x. We're going to change the signs in front to negatives. So if they're positive, change it to a negative. If it's negative, change it to a positive. The reason for that is we're going to be able to now add these equations together and simplify what's inside of our division sign a little bit further to help us find the final answer. Okay. So we'll do x squared minus x squared, right? We're going to add those two equations together. What's x squared minus x squared? Yeah, they just cancel each other out. And a lot of times that's what's going to happen. That's why we change the sign, right? We're going to keep working down with all the other terms inside my division sign. What's negative 8x minus 2x? Careful. So you have negative 8 minus negative 10x. Okay. And then I have that negative 26. Well, very similar to normal long division. If I had anything left over, I would bring that down. And now I have negative 10x minus 26 left over. What I do from here is just repeat that process, right? So I'm going to ask myself now, I'm going to look at the first term on the outside and the first term on my inside after I simplified everything. Ask myself the same question. What do I have to multiply x by to get to negative 10x?
Negative 10.
Negative 10. And then I take that negative 10, I multiply it again by all of the numbers on the outside. So negative 10 times x is going to give me what? Negative 10x. Negative 10 times 2 is going to give me what? Negative 20. What do I have to remember to do with each of those signs, though? Good. Change them so they're both going to become positive. And then I add those things together. Well, what's negative 10x plus 10x? They cancel out. Negative 26 plus 20, negative 6. Well, let's pause there for a second. Does anybody have any questions up until this point? A lot of it's just a repetition of the same process over and over again until we get to this point. The reason that we're going to pause here for a second is I have an x on the outside, so I'm always going to work with that first term. But there's no way I can get from x to negative 6, okay? So very similar to long division. Remember, sometimes you had what was called a remainder, right? Those numbers that are left over. Well, this is our remainder here, okay? what our answer is the number that's on top of my division sign. So if I were to take this and I were to ask you what's x squared minus 8x minus 26 divided by x plus 2, your answer is x minus 10. Okay. And the way that we write our answer, if you have a final answer in the terms above your division sign, that's your final answer. That's what we just talked about. If there's a remainder left over, here's how we write our answer. The terms on the top of my division sign, so the x minus 10. We have a remainder of -6. We take that remainder and you'll write this answer over top of the expression on the outside. So the expression that I started with on the outside of my division sign was x plus 2. So how I write my remainder is -6 divided by x plus 2. And this is my final answer for this problem. Okay. You take what was written on top of your division sign, what allowed you to say, okay, x plus 2 goes into x squared minus 8x minus 26 evenly. And then whatever the remainder is, you write that over the term on the outside. So this is your final answer. Okay. Any questions about that first example with polynomial long division? Okay. We're actually going to put a pin in this for a second. We're going to move on to what's called synthetic division. All right. And we're going to do an example of synthetic division to show this process, and then we'll kind of review the two. And again, whatever we do in class today, we're also going to be doing tomorrow. So if something's a little unclear, we'll definitely, going to have some review on this moving forward. Okay. Synthetic division is a very similar process. So we're dividing either a trinomial, or you see here, we have multiple terms by a binomial. However, this one just deals with coefficients. It's an easier way for us to kind of work with just addition and subtraction of numbers rather than variables. And you'll probably prefer this method over long division to help us solve. All right. Very similar to what we did before. We'll take this step by step. I have 2x cubed minus, this should say 13x squared. So make sure you make that revision. There's just a little typo there. So 2x cubed minus 13x squared plus 26x minus 24 divided by x minus 4. Okay. The first thing that we're going to do, we're not going to set up a long division or anything like that. We're going to take that x minus 4, set it equal to 0, and solve. And when you do that, you get x equals 4, right? So that first bullet point there, you're going to set the binomial, so the two-term expression, equal to 0, and then you're going to solve. Everybody with me so far? That's always going to be your first step with synthetic division. You're going to take that number now, and then we're going to set up our problem this way. We're going to take that 4, kind of write it off into a little box off to the side. And then we're going to list the coefficients of the other expression there, the other polynomial, in order based off of what the highest exponent is. So I say I have 2x cubed, I'm going to write the 2. Negative 13x squared, I'm going to write negative 13. 26x, I'll write 26. Negative 24 is my constant term, I write negative 24. One thing that you need to keep in mind, another thing that's bolded there, is if a term is missing in the other expression. So say you only had like 2x cubed plus 26x and no x squared term, you would fill in that blank with a 0. Okay. something that you might see on your homework tonight. If you are missing a term, don't just list them out. Make sure you include a 0 there. Otherwise, you're gonna probably make a mistake somewhere along with your simplifying. All right. Any questions so far? So this is our setup. Just kind of rewrite this here. What we're going to do to start is bring the first coefficient down below this line and multiply it by the number in the box. So the first coefficient I see is that 2. I'm going to bring that down. And one thing to kind of help you out here is anything below the line, you're using multiplication with the number in the box. Anything above the line, you're adding and subtracting. Okay. So I bring the first coefficient down, I multiply it by the number in the box. So I'm going to do 2 times 4, and 2 times 4 is going to give me what? 8. I'll write this product underneath the next term. And then I'm going to add those values together. So what's negative 13 plus 8? What's that? So that would be negative 13 minus 8. Negative 13 plus 8. Negative 5. Good. Okay. Any questions so far about what I just did? So I brought down the 2, multiply by the 4. I write that product here. Then I do negative 13 plus 8, which is negative 5. I write that sum there. Just going to rewrite this out real quick. Bring down the 2. 2 times 4 is 8. Negative 13 plus 8 is negative 5. Like I said, anything below that line, you're multiplying that number with the number inside the box. So I'm going to do negative 5 times 4, which is what? What's that? Negative 20. And then I'm going to add those two things together. So what's 26 minus 20?
6.
6, good. What do I have to do with this 6 and the 4? And what's 6 times 4? 24. What's negative 24 plus 24? 0. All right, let's pause right there. Is there any questions about this process so far? So I continue this until I get to the final, term there, which is that negative 24. If your work ends with a 0, so this note here, if the work ends with a 0, this means there's no remainder. So back when we were doing the long division, we saw we had a remainder. In this case, if you were to do long division here, you would get no remainder, or you get 0 underneath your final term. Okay. What we do now is assign x values to each of these. So 2, negative 5, and 6. Remember back in when we were just doing long division, let me just pull this up real quick. Our final answer had x's in it, right? It had variables, okay? So our final answer here should also have variables. The way that I think is best to do this is to start with this last term and then work your way this way. So 6 is going to be your constant term, right? So you'll just write 6. Negative 5, well, you go from constant terms to x terms, right? So your next highest variable would be negative 5x. What would be your next highest variable after x? Instead of x to the first, it would be x squared. So it would be 2x squared minus 5x plus 6. This here is your final answer. So notice that we don't have any more terms going in this direction, right? So you can only go as high as the amount of terms that you have, right? So there is no x cubed term. You might see examples where you only have an x and a constant term, right? It's just a matter of how many terms you have. In fact, one thing that you might want to keep in mind, notice that you start with an x cubed and you're dividing by an x term. Remember, what's x cubed divided by x? X squared. So you should end up with the highest term being an x squared. That's another thing that you can keep in mind as well, similar to how we were doing simplifying before, right? X cubed divided by x, that'll give you x squared. So that should be the highest term that you have in your final answer. Okay. Any questions about that process, synthetic division? Is that a lot easier than long division?
They're both just like a lot.
Both kind of a process. Okay. I think this one might be easier to deal with just because there's no variables involved, right? You're just doing addition and subtraction. All right. Let's do an example together here. We'll do this. Oh, hold on one second. We'll do this first example here. We'll do long division. The second example, or another example down here, we'll do synthetic division. Okay. So this first one here, we'll do long division. We have x plus 2 dividing into 3x squared plus 7x plus 2. Okay. What do I have to multiply x by to get to 3x squared?
$3x.
Yeah, 3x. I'll take that and multiply it by each of these terms here, right? What's 3x times x? 3x squared. What's 3x times 2? 6x. What do I have to do with each of the signs there? They're both positive. What do I have to do with these? Right, change them to a negative. These will cancel. What's 7x minus 6x? X. And what do I do with this 2 out here? Bring it down. Okay. Any questions so far? So how many times is the first term going to that first term? Write that above. Multiply those through. Change the signs and simplify. Bring down any terms left over. Well, what do we notice that's both on the outside and underneath my division sign right now? Well, how many times does x plus 2 go into x plus 2? Once, right? How many times does anything go into itself? With the remainder, this would actually cancel out. Remainder 0. So what's my final answer here? 3x plus 1, right? It's whatever is written above my division sign. And there's no remainder. Okay. Any questions about that long division example? Okay. Let's take a look at this bottom example here. We have x cubed plus 3x squared minus 4 divided by x minus 1. We're going to use synthetic division for this. Remember, in synthetic division, I start by taking that binomial and setting it equal to what? 0, right? And then I solve. So x minus 1 equals 0. Add 1 to both sides. I get x equals 1. Where do I put that 1? Right, in the box off to the left. Give everybody a chance to catch up here. Any questions up until this point? Everybody with me so far? So you just take the binomial, set it equal to 0, put that number in the box here. What do I have to write across the top here? Okay. Close. So yes, we have to write 1, 3. But remember that note that I made earlier. If there is no term there, if there's a missing term, we fill in that blank with a 0. I have an x cubed term, an x squared term. I don't have an x term, right? So I have to write a 0 in wherever I don't see an x, and then I can write the -4. All right. It's really important that we make sure to do that. Okay. I'll draw my line. Somebody from home, tell me what the next step is. What's the next thing I need to do?
Bring down the first number.
To bring down that first number, which is 1. And then what do I have to do with this 1 and this 1?
Multiply them.
Multiply them. 1 times 1 gives me 1. I'll write that there. What's 3 times 1? Or 3 plus 1, excuse me. 4. What do I have to do with the 4 and the 1? Multiply, I get 4 times 1, which is 4. 0 plus 4 gives me 4 times 1. -4 plus 4, 0. When I get a 0 there, what does that mean? What do I not have? There's no remainder. Good. Just kind of thinking about this problem, what should my highest exponent be if I'm dividing an x cubed by an x? X squared. So you can either work backwards like I showed you earlier, or if you know that, if you recognize you have an x cubed divided by an x, your highest exponent is x squared. This would be 1x squared plus 4x plus 4 for your final answer. Okay. Any questions about either of those processes? So we've seen simplifying, which we saw a little bit more yesterday and earlier today. Any questions about polynomial long division or synthetic division?
Yeah, Mr. Stackhouse, for this synthetic division,
Yeah,
when you have a remainder, would you just put that number over the binomial?
exactly. Just like before.
Okay.
So just like in long division. Really good question. Any other questions? Okay. Give me 2 seconds here. I'm just going to pull up the